Good afternoon. In today's lecture, we will be talking about a little about software requirement specification document, that is the SRS document that we were talking in the last lecture, and we will be starting a new topic today, that is software project planning. So without much ado, we'll just quickly start with what we had discussed in the previous lecture about software requirement specifications. So we were talking about software requirement specification, that is basically it is a document which is useful in various contexts, because we have seen that after a long and a tedious process of inquiry, interview, conversations, dialogue between the clients and the software provider, we come to a consensus, the two parties, they come to a consensus as to what is required of the new document. And we had also seen the various attributes of a software requirement specification document, which are desirable attributes. So basically this document is a very important document in the entire software development life cycle, because this is going to work as a statement of user needs. Primarily this is the document which will establish, which will be used as a proof of what the user desires, what is the user's requirement, what is his expectation of the final software which is going to be developed. So basically it requires, it specifies all the user's requirements. Next, it becomes a contract document, because this also talks about whatever the software will is expected to do, and also it will restrict the scope of the project. So it will contain the scope of the project, it will limit the scope of the project to what it is exactly going to do. Next is the reference document, because any time there is any point where there is a conflict, or where there is any doubt, or where there is any dilemma about the requirement, or when there is a contradiction in the requirements, then this document will serve as the key point. It will show light on what is right and what is wrong as the requirements of the users are concerned. And then finally it will also be the next input for the next stage, that is, it will serve as an input for the design, and it will lay the definition for the implementation of the software. So basically it will serve as an input guide, it will serve as a guide for the next phase, as in what is going to be the design, because if requirements are clearly defined, then obviously all the other things will fall in place. And if this document has some form of errors, or if this document is not a perfect document, then certainly those errors are going to percolate into every step of the system. Because if you do not understand, if the company, the software developer does not understand what is required of the software, then obviously it will be very difficult for him to make a software which will fit into or which will meet the expectations of the user. So basically this is a document which will be required in, or which will serve for multiple occasions and for multiple contexts in the software development project. Now basically it will describe two types of requirements of the user. So it will describe the functional requirements and the non-functional requirements. So functional requirements, basically these are a set of high level requirements which basically specify what the software is going to do, exactly what is the project going to do, that is in the sense of input and output. So these are high level requirements which are written in generally, which are taken from the user, and these are the what output the system is going to give to the user. So they consist of some identifiable function which the user has easily identified, and these are stated in a language which is generally the user's language, because ultimately the functional requirements are to be anchored to a specific user in the entire project. So basically these are high level requirements of the user which come from the user, and they define what is the input and what is the output of the entire project or entire product which is going to be worked on. So basically for each high level requirement, every function is described in terms of input data set, in terms of output data set, and in the terms of the processing required to obtain the output data set from the input data set. So basically it only talks about the transformation of the input to the output and what all manipulation or what all processing the data will undergo as a part of the entire software program. So these requirements are very clearly defined, and there is very less ambiguity in these, because these are, as we are again and again saying, these are user specified requirements. So since a user is specifying these, so generally, and these are direct requirements for which generally these are the primary requirements for which the software is being developed. So therefore there is generally these requirements, they are clearly defined and they are supposedly clearly understood by the user as well. So then the other set of requirements which the software requirement specification document talks about are the non-functional requirements. So the non-functional requirements, these are rather more difficult to quantify, these are more difficult to achieve, and these are very critical. These are even more critical than the functional requirements, because if the non-functional requirements are not fulfilled, then in that case the system is bound to not meet the requirements of the user, and it is bound to be not a very desirable, and supposedly a failure of the system can take place if it doesn't meet these non-functional requirements of the users. So these are basically which are those requirements which are expressed in the functions of maintainability of the system, portability, usability, fault tolerance, recovery, security. So basically it talks about all the non-functional aspect of the system, but with the aspects which are very critical for the success and failure of the system. So non-functional requirements are very critical, and therefore they must be met in by the software. So these are critically defined in the software requirement specification issue. So these may also sometimes include like reliability issues, performance issues, then human computer interface issues, interface with other external systems, security, etc. So when we are saying human computer interface issues, we are meaning how the user interface has been designed, because these days we see that the user interface becomes a very important aspect of any software. If the interface is attractive, if the interface is easy, then users get attracted to that software and the software becomes popular and it gains popularity. So basically designing the interface, there are several tools which are available in today's date which can be employed by the developer for designing a great graphical experience for the user and providing a high level user interface experience for the all users of the system. Also, when we talk about the interface of the system with external systems, so basically this means that the system, how the system will interact with other external system, maybe some statutory bodies are involved in it, or maybe some other forces are going to work on it, or how the changes which are occurring in the environment of the system, how is the system able to adapt to those changes. So these are also the requirements from the user. For example, if you are developing a payroll software, so the user will obviously want that whenever the new rules for the calculation of pay are out by the government or by by the authorities or by the statutory bodies, then your system must be able to adapt to those new changes. Or if some minor, say for example accounting software, so if there are some minor accounting changes which are occurring, then your system should be able to absorb those changes, and it should be able to, it should be modifiable in that sense. So basically what we are saying is that the functional requirements are those which are specified in the terms of input, output and process, and non-functional requirements, these are specified or these are defined in the form in various terms. Some of these could be even subjective, some of these could be objective, and some could be measured with the use of some measurable, quantifiable tools and methods. So, and besides this, the system must also describe, or the system requirement specification describes one very important aspect of the system, which is called the constraints. So constraints basically are the limitations, or these are the binding forces under which the system has to work. So constraints could be, several types of constraints could be working on a system, and all these constraints must be very well defined in the requirement specification document, because these will make sure that the system has been developed keeping in mind all these limitations which the prospective system has to follow. So these could be like standard compliance. So if the system has been developed for a particular industry in which there are high standards of compliance which need to be maintained, so the system should be able to meet those standards. Then if there are some industry standards otherwise other than the domain specific standards, then the system should be able to. Then if there are some hardware limitations, for example, if the user if the company has some systems with them and they want to utilize those systems, so in that case, that the configuration of those computers, the hardware which is available, can become a limitation. Or if the company has some other, like for example, they have a shared printer, now they don't want to get another printer, so you will have to define the software, you will have to create the software in a way so that it allows all this kind of limitations, it accommodates all these kinds of factors in its processing. Then there could be other issues like reliability and fault tolerance. Some systems, they are very critical and they have to be fault tolerant. So this can be achieved through redundancy or through any other channel, but for the downtime is not allowed, for instance. So those systems which have a high reliability quotient and which need to be highly fault tolerant has to be figured in, has to be factored in while the software is being developed, and this also forms a part of the requirement specification document. Then there can be requirements which could be the most critical requirement, could be the security of the system. So a software like which has been defined or designed for the armed forces or for the air force or for the defense services, so in there the most critical requirement which will come from the client's end will be that the system should be highly secure, it should be very protected, and there should be absolutely no vulnerability as per se as far as information theft or any kind of hacking or cracking etc. is concerned. So in that case, the security aspect of the system becomes the critical aspect of the system, which needs to be clearly understood and needs to be clearly defined by the software developers in the software requirement specification itself. So now we can see that there are various users of the requirement documentation. We've already prepared a requirement specification document, and we see that a couple of users are there in the company which will use this requirement specification document. So the first among this is the system customers, or the people for whom the software has been developed. So they specify the requirements and then they read these requirements, that they check whether they meet the needs of the system or not. Then they are the managers. So these managers, they use the requirement specification document to plan a bid for the system and to plan the system development process. Then we have the system engineers who use the requirement specification to understand what system is to be developed. Then we have the system test engineers who use this requirement specification document for validation tests etc. And then we have the system maintenance engineers who will use this requirement document which we have prepared for the management to help understand the system and also to find a relationship between the different parts of the system can be maintained using this kind of document. So we can see that across board there are a number of users who will refer, who will anchor to this one specific document for various requirements. So there can be the customer who will use it for understanding the system. It may later on serve as a documentation model, document for understanding the system or the various aspects of the system or how the requirements have transformed. And then from those, the managers, the engineers, and the system engineers and even the maintenance engineers. So everybody, every stakeholder in the development process will be using or will be referring to this requirement specification document at one point of time or the other. So basically it will the requirement specification document, it specifies the external behavior of the system, that is how the system is going to behave with its environment, with the actors and factors which are in the environment, like the statutory bodies, the clients customers, the suppliers, etc. Then it will specify the implementation constraint, the various constraints that we have discussed, like hardware or software constraints, or security constraints, or maintenance constraints, etc. Then this requirement specification document must be easy to change, because if it is not easy to change, then it will become very rigid and will become difficult, because we understand that the requirements of a customer, they keep on changing, they are actually in a fluid state. So basically, to accommodate the changing requirements, we need the document to be flexible enough to accommodate those changes. Then of course it serves as a reference tool for maintenance. Maintenance of the system will come once the system has been working and has been implemented, it's working successfully, but still there will be periodic maintenance which will keep coming in. So this maintenance, for this maintenance also this will serve as a tool. And then it will record the forethought about the life cycle of the system, that is, it will predict how the system will behave in the future, what are the changes, and it will characterize responses to unexpected events. So if there are any risks or any kind of unforeseen event which will come, so then these should also be a part of the requirement specification document. So those unexpected events can also be a part of this requirement specification document. So basically this is going to be a very important and a key document which is going to help the entire process. So according to the standard, the IEEE requirement standard, the generic structure could be of a requirement specification document could be an introduction, then there is a general description, then the specific requirements come in, then the appendices and index. Of course, this is a generic structure and this can be instantiated for a specific system. There could be additions to this, there could be some appendices or something which is not required, or something which is required in greater detail. Of course, all that the flexibility is there, but this is a broad outline according to which generally the software requirement specification document is prepared by the software team. So basically the structure that we just saw is like, it will have the requirement definition, it will talk about the architecture of the system, then it will talk about the requirement specification in detail, then it will also give a layout of the system models, how the system will evolve, and the appendices and the index. So basically this is a structure of a typical software requirement specification document which is used as per the IEEE standards. So once the requirements have been specified, the next very important step is of validation. That is, it should not contain any errors. So it specifies the client's requirements correctly. So because while a requirement specification document is being prepared, there is a lot of room for misunderstanding which can come in. So basically, if the requirement specification has errors, then obviously those errors will be reflected in all the future, because if the requirements are not understood clearly due to any reason, then of course those errors are bound to reflect in the next phases of the requirement specification. So validation means that the requirement specification document must be reviewed by a lot of other people, by a number of other people, so that it reflects the accurate requirements, and the most important thing is clearly. So a good quality requirement specification document must specify the requirements of the user, and it should be validated for having for being precise, clear, and also correct. So it should be written in unambiguous and precise language which is understandable by the engineers as well as the client. So it should be mutually, it should be a language which is mutually understood. If it is in too technical language or in using too many semantics or models, then it may be difficult for the user to understand and the user to comment or point out any errors which have come into it. So therefore, it should be in a language which is easily understood by the user. So basically, when you talk about errors, so there are several errors, several types of errors which can come in a requirement specification document. So the errors could be, omission errors or inconsistency, or there could be incorrect facts, or there could be errors due to ambiguity. Now omission simply means that while the requirements were stated, so the particular requirement was omitted by the user. Omitted by the user due to several reasons. It could be because it did not strike the user at that particular time, or the user thought that he assumed that it would be automatically be understood. It is he would understand that it is implied sort of thing, so he did not explicitly mention it. So therefore, the requirement was omitted, or it was completely missed out, or even the engineer was not able to record that requirement or understand that requirement correctly. Inconsistency means that the same requirement comes at different places in the requirement specification document in different forms. So therefore, it is a situation where the engineer will be confused, as in the same requirement has been put in differently by different people. So therefore, there has to be some consistent way in which the requirements are stated. Sometimes the client who is stating the requirements is himself or herself not very clear of what the actual state is. So he may he or she may state some facts which are not correct for the organization, or his knowledge himself is not true to the best. So therefore, in that case, those incorrect facts become a part of the requirement specification document, and they will be pointed out as being errors. Then one of the very important and very critical errors which come in the requirement specification document is ambiguity, because we understand that this is a conversation between people who belong to two different domains of knowledge. So therefore, there is bound to be some kind of ambiguity, or not the same multiple meanings can be drawn of the same statement. So therefore, in that case, what will happen is that the user may state something, but the understanding of the engineer may be different from that. So in that case, there will be ambiguity in the statements, and hence those ambiguous statements can never be implemented correctly, can never be shown or reflected correctly in the requirement specification document. So ultimately, this will lead to a lot of error in the software requirement specification document to come in. So therefore, in order to validate this system and in order to make sure that the system is free from all types of errors, an important step which is taken is the requirements review. So requirement validation involves that both clients as well as the user. So review is done by a group of people to point out errors and other issues of concern in the requirement specification document. So review may basically, the exercise is to keep a large group of people from the client's end, whoever is going to be the primary decision maker in using the system has to be a part of it, so that they can understand and they can review it. Also, it is used to consider factors affecting the quality, like testability, readability of the system, etc. So there is a checklist of requirements which is prepared, like what are the hardware, what is the data interfaces, what is the external software, etc. So all these requirement checklist is prepared, all these requirements are defined properly, and then these requirements which are defined, and then the requirement review is said to be complete. So both the people from both the sides sit in and they go through it, they study what are the requirements which have been specified and what are the other kind of interfaces, constraints or non-functional requirements of the system also have figured in correctly. So basically, this was about software requirement specification document and its important attributes. We have also discussed about the structure of the requirement specification document and how important it is for to review the requirement specification document. So now we are going to start with the next part or the next topic of this today's lecture, that is software project planning. So basically planning is a very important activity in any exercise, because if the things are not planned properly, so no matter how good tools and techniques are there, but still the project or the entire activity or the entire task is bound to fail. So therefore project planning becomes a very important aspect in case of software management. Sometimes this project planning becomes a part, it is actually a part of a 3-phase project management science which is studied. So in project management basically we talk about 3 phases, or we talk about 3 steps. One is project planning, of course, the first step, in which the entire project is planned, the schedules, the estimates are done, a number of exercises are taken under, and the planning exercise is done. Next is monitoring and control. So once you have a plan and the work starts, then you can monitor and control the activities which are taking place in the project, and you can see, and you have measurable quantities and you have some planned quantities, so you can compare and you can see whether things are going accordingly or not. Of course, quality control becomes a very important aspect here. And then finally we have the project termination state. So in project management we basically discuss these 3 things, that is project planning, monitoring and control, and how the project will be terminated, that is after implementation, how the maintenance and how the services will be provided to the client. But of these, the most important becomes the project planning, because if things are not properly planned, then there is a lot of error, or there is a lot of discrepancy which may come in between the requirement specification and between the actual product. So planning becomes a very critical exercise in this whole thing. So project planning, basically planning always comes before development. So before you start working on a system, it is important to prepare a systematic plan on what is to be done, how it is to be done, and what are the tools which are required. So when we are saying when we talk about project control, so basically the plan has been executed and it has been updated. So now when the plan is executed, you need to control how the things are going on, and what are the points where you need to intervene, or what are the points where you need to work on. So basically if you fail to plan properly, so there will be a great chance that the project will fail. A failure to plan means a failure to implement. So therefore a plan has to be prepared by looking into the future, identifying the activities, and planning and scheduling all resources which will be required. So basically in case of software project management and software project planning, the requirement specification becomes the input, or becomes the primary document which will be used as the preliminary document for the entire planning activity. So taking the requirements in view, then the plan is prepared, and after the plan has been prepared and it has been agreed upon, only then in designing or the future activities or the further activities will take place. So basically project planning, the major issues which are addressed by project planning are process planning, then effort estimation, then schedule and resource estimation, then we have quality plans, then configuration management plans are made, risk management is done, and then finally project monitoring plans are done. So project planning is a very, very comprehensive exercise which entails a large number of areas, in fact all the areas which are a part of the software requirement or software development process. So in this case we are going to prepare the plans, and we are going to schedule how the activities are to be done. We are going to estimate what are the resources which will be required for the particular software project to be undertaken. Then important thing will be how to check the quality or quality control. For that a quality plan will be prepared to see whether the software meets the requirement standards, or whether the software is of a good quality software or not. Finally, the configuration controller will prepare the configuration management plan to see that whether the software has been configured according to the requirement specification. And then there is a risk management plan, which is again very important in case of large software products, because there is a very huge amount of risk running in those projects. And finally, we will prepare a plan to monitor each activity and each task which is being done in this. So now we are going to discuss about each of these issues which will be addressed as a part of the project planning. So the first is process planning. So basically, in process planning, one specifies the various stages in the process, that is the entry, the exit and the verification activities. So when you are selecting a standard process model and tailoring it for the specific project need. So tailoring basically means that you are modifying, omitting, adding or one or more steps in the standard process model. So basically it guides the rest of planning activities. So how the software process is going to work. So basically there are a lot of standard models which are used. We've already discussed those software process models which can be used, and each of the software is different from the other. So there cannot be one standard, one size fits all. Therefore, an important aspect becomes that for each individual project, the model has to be changed a bit according to to best suit the requirements of that specific project or that specific product. So basically tailoring will be required for this, that is customizing that the project model, the process model, and making it best suitable for the current project which is being utilized. So after the process has been planned, after it is decided what are the steps which are going to be done, the next important step which comes in is the effort estimation. How to estimate the cost of the project is very important. So in this effort estimation, basically two things are done. One is cost estimation and the other is schedule estimation. Cost estimation is very important because based on this estimation only a cost benefit analysis of the project can be done. Cost benefit analysis of the project can be done by the customer, because he will understand that if I am paying so much money towards the cost of the project, what are the benefits that are accruing to me. So the cost benefit analysis is only done after the cost estimation has been done by the project manager. So basically this activity will also help in project monitoring and control, because once the schedules have been prepared, only then when the plan all activities have been planned, there is a start date and end date for each activity, only then you can control how the activity is progressing, and you will have to see that these all the schedules they fall in line, so that ultimately the entire project is able to meet its deadline. Then we have to see that in software the primary input which goes in is human, because we understand that software industry is a knowledge based service industry. So the most important input which goes is people. So therefore the effort which is calculated, or the input which is calculated in terms of person months, which generally we say is PM. So person months means that if we say that this specific project will require 56 person months, so it means that one person working for 56 months. So we can also say that it requires, if we are employing a team of 8 software developers, so then the same project can be completed in 7 months. So basically this will estimate the effort, the person months will estimate the effort, and when we add the overheads to the person months, like overheads will include the hardware costs, the software costs, the office space and all the other additional costs. So when you add both these, the person months to overheads, then you get a general total cost estimate of the project. So because there are so many uncertainties in effort estimation, it depends on which phase the project is in. So when you are estimating the cost of the effort required, you are estimating how much effort is required, it becomes very difficult to estimate the effort required at the beginning of the project. So if you, for example, if you want to estimate the effort required at the time of feasibility study, or when the company is just brainstorming about the project, then the effort estimation will be very different from, for example, if you are calculating the effort at the time of designing. Whereas vis-a-vis, if you think that a project has been completed and then you are asked to estimate or to calculate the effort which has gone in, will give you the most accurate idea of how much effort has gone into that estimate, into that particular project. So basically, effort estimation can be done at any stage in the project life cycle, and each stage, the later the effort estimation is done, the more accurate the results will be. So basically, effort estimation is done based on two models. One is the top-down model and the other is the bottom-up model. Now in top-down model, what is done is that the estimate for the entire project, the effort estimate for the entire project is done first, and then this effort estimate is then divided into individual task by task activity. So you calculate that the total cost or the total estimate required for a project is so many person months, and then you divide that into individual activities which will be required for that project. The second approach to estimate the project effort will be the bottom up approach, in which you need to understand what are the different activities which will be required, what are the different tasks which will be required in order to complete the project, and then together you sum up those activities and those tasks to finally build up the cost or the effort of the entire project. So these are two different approaches. In one, you need to know the total cost of the project in the beginning. In the other, you need to identify what are the different activities which are going to be done or which are going to be undertaken for the project, because only when you recognize the activities or only when you recognize the individual processes can you understand what is going to be the cost for this. So these are two different models of project estimation. After the estimates have been prepared, then the next important step which is taken is the project scheduling and staffing. Scheduling basically means that you are giving the time frame or you are giving the activities when each activity will begin and when each activity will end. So here you have we have the manpower and we have the months which are required, but these are not fully interchangeable in a software project, because you cannot directly say that if a project requires 56 person months, so 8 people can do it in 7 months, because there are so many other subjective elements also which will take place. There will be some unforeseen circumstances which will be beyond the control of the project manager. So all these things have to be kept in the loop in order to see whether the project is working as per schedule or not. So basically, when you are talking about project scheduling, the major tasks which are there, these are broken into smaller schedulable activities in a hierarchical manner. So scheduling basically is an iterative process, because the project manager has to go on preparing the schedules, because as and when the activities change, the schedule has to be redone again. So if one activity is behind schedule, so that will, because there is the activities, they have an interdependence on each other. So if one activity goes beyond schedule, then obviously the schedule for the other activities also is disrupted. For example, you cannot have the testing activity, you cannot start the testing activity unless the coding activity has been completed. So if the coding activity goes falls out of schedule, then obviously you have to reschedule the testing activity. Of course, also you have to see the availability of resources which are required for each activity. So the activities have to be scheduled so that the efficient use of all resources, all dependencies are also taken care of. So there are several tools which are available today, which are very good project scheduling tools, which require, spreadsheets are there, and Microsoft Project is another very important and very popular tool which is used for scheduling activity. So these tools actually they take into consideration the effort, the duration for each project, and what are the dependencies. So all these are specified, and then the project scheduling report is prepared. Now again, this detailed project report is dynamic. It cannot be a fixed report, because whatever changes come, there could be some unexpected, unprecedented changes which have come in. So all these changes have to be factored into the detailed project scheduling report. So basically this activity is the one which requires a lot of experience on the part of the project manager or on the part of the team leader, whoever is doing this. The next activity is of staffing or getting people into the team. So as we understand that it is a completely human resource dependent industry, so we have a lot of paradigms according to which people are hired and teams are built in case of the software industry. So there are several structures in which people can be hired and they can be put in. So the team structure is a very important aspect. So we have three types of team structures basically. In the first type of team structure, we can see here it's a hierarchical structure in which there is one senior project manager. He is the project manager is basically a person who has good experience, and under him there are several other people who will be working. So it is the responsibility of the project manager to prepare the schedule and to appoint people and to assign tasks to each of these people. So the different people who are working under the guidance of the project manager are the programmers. Then these are the people who will be doing the coding. Then there will be the testers who are doing the testing part of this system. Then there will be the configuration control managers are there. Then there could be probably a librarian who is required for the documentation purposes. Then there will be network managers, there could be database manager, and there could be several other people. But basically they all work under the guidance of the project manager here. Another important thing to note here is that these are specifically the logical roles which have been put here, and this is not necessary that individual people will be doing it. So there could be multiple people in depending on the size of the project. There could be multiple people who are doing each activity, or there could be one person who is doing multiple activities in this. So basically the point to understand here is that these are logical roles and these are not individual persons that we are trying to represent here. Now the second type of team structure, which is more democratic, and hence it is also called as the democratic or egoless team structure, is where you have a group of 10 to 12 software programmers or software developers who work as a team. So in this case there is no hierarchy, there is no manager, and they are all the same, and this type of there is a free flow of ideas here. So there is nobody reporting to anyone, everything is done on a consensus. The entire team sits together and takes decisions as in pertaining to scheduling, as in pertaining to task distribution and other aspects of the project, even the cost estimation. But this kind of team structure is more popular in projects which are more research oriented and where the time deadlines are not very critical. So they have their time and they have time to discuss, they have time to talk, and they can easily work out the thing. Now the third type of team structure, which is very common and it is used in big corporations like the Microsoft, is a different kind of paradigm, where we understand that the software development is an exercise which has basically three separate domains. The first is project management domain, the second is project development, and the third is testing teams. So there are 3 teams which are there, and in each team is independent of each other, and for each team there is a hierarchical organization which is maintained. So under each there is a unit head who will look after the activities which are which are being done by each of these teams. So basically this type of team structure is an amalgamation of the hierarchical structure as well as the the democratic kind of structure, because there is hierarchy but then there is also a free flow of ideas, and also the work has been clearly defined, the boundaries of the work have been clearly defined. So therefore the expertise of the people can be put to best use. So the people who are developing they are more into development, and therefore they are excluded, or they are freed from the task of the testing and all those activities. So this is about team structure and how staffing and hiring can be done. So according to the team structure which has been chosen for a particular software project, the people are hired, and this also becomes a part of the scheduling exercise as a part of the project planning exercise. Then the next step which is done is the software configuration management plan. So configuration controller is the person who will be doing the configuration management planning. Now in this case different activities are undertaken by the configuration manager. So basically in this you have the the configuration manager, he identifies the configuration items, then he decides and he defines the various naming schemes for the different stakes. Then he also defines the directory structure which will be used in the software. Then access restrictions are defined in case of for the software, who are the users, how and what will be what they will be accessing. Then they define the change control procedures, how if any changes are to be made, what are the main steps and what are the checkpoints to be followed. Then they define a backup procedure, and they also define a release procedure for the software. So basically configuration management exercise is a very comprehensive and very important exercise of the software development project, which is undertaken by basically the person who is the configuration controller, who will see how the system has been configured and how the software will work under different under different conditions, and how the system can be controlled, how the versions of the system, different versions of the system can be controlled and configured. Then finally we have the quality plan, that is basically quality is defined in terms of delivered defect density. So this is one of the most common ways in which today quality is defined for software. That is, delivered defect density means that is number of defects per unit size. That is, what is a defect? Basically a defect is any function of the software or anything in the software which is not as per the requirements of the user. So anything which the system is doing and is not required by the user, was not specified by the user, is a defect. So how many defects are delivered will decide the quality. So therefore the important aspect of quality ensuring the quality of the software is defect removal. So basically whenever there are defects which are found in the software, then active strategy is used to remove those defects. But because of that, while defect removal is done, there will be other changes which will be coming into the software. So for this there is important to have a proper and a systematic quality plan. So the aim of the quality plan should be to specify activities that need to be performed for identifying and removing defects, and the tools and methods that may be used for that purpose. So for ensuring that the software is of the desired quality as required by the user, and there are least the minimum defects are there. So for that a proper quality plan is to be prepared. So for quality plan there is also a mechanism of quality control. So these are checks which are put in. We cannot say that if the quality of the final product will be good, even if the quality of the individual phases of the software is not good. So that is not possible. So if we are saying that the software has to be of a considerable good quality, then in that case the quality of each of the intermediate phases, each of the intermediate outputs, like the requirement specification document should be of good quality, the design should be of good quality, the coding should be of high quality. So if for each step the quality has been maintained, then in that case the quality of the overall software will also be of high standards. So basically it is throughout the project that the quality control activities have to be performed and the quality has to be kept in mind. So quality control activities are requirements review, design review, then code review, then unit testing, integration testing, system testing and acceptance testing. So basically to ensure quality, each step of the software development process has to undergo a review and testing. When we are talking about quality, there are two important terms which are very commonly discussed, that is verification and validation. So verification basically means that the output or the working of the specific phase of the software, it conforms to the previous phase. Like for example, if you are in the design phase, so the design should refer to the requirement specification document. If you are in the coding phase, then the code should refer to the coding to the design. So basically verification means that whether your present or whether the output of the present phase is in consonance with the output of the previous phase. And validation is an exercise to make sure that the software is as per the requirement specification document. So once the software has been complete, once the the product is ready, then it is validated against what the requirement specification specified or what was expected of the software. So these two activities are carried out, verification and validation, to make sure that the quality of the software is as per the requirements. So after the quality control and the quality plan has been taken care of, then we have the risk management. So basically a risk is any adverse effect on quality, cost or schedule. Any incident or any event which is going to affect the quality, the cost or the schedule is termed as a risk for the software. So basically what we are trying to do in risk management is to minimize the chances of failure caused by unplanned events. So because this is a very important activity, even though we understand that there is an attitude that we have generally we have the societal attitude is a very optimistic attitude, and we suppose that any unprecedented or any negative thing will not happen to a specific situation, to our persons, but when such circumstances happen, then all the things can go out of control. So therefore, if it is a large software project, then risk management strategy is one of the best practices for any software developer or any project manager to adopt. For example, there could be several strategies. One is like if you are building a house and you know that the house is, if there is going to be an earthquake, the house is going to be destroyed. So in that case, there are several things that you can do. One is that you can shift the site of the house to a place where no earthquakes come, which is quite unrealistic, or you built a house using some technology so that the house becomes seismic tolerant. So there is another. So basically for risk management in software products also, there are different kinds of approaches which can be used. So the risk management approaches can be classified as risk assessment. So in case of risk assessment exercises, we talk about risk identification, in which the various risks which can be possibly affecting the software can be studied. Then we have risk prioritization, that is the risks, they are put in an order: high priority, low priority, high incidence, low incidence. That is, those risks which have a high priority, which can cause more damage, have to have a mitigation plan those which are low priority can be postponed. Then we have a risk analysis in which we see that how much damage will be caused. So it's like a cost analysis of the threat and the effect that risk is going to cause to the system. And then we have the second strategy, which is risk control. That is, how do we control the probable risks or the events which can harm the system. So in this case, we can have risk management planning, we can have risk resolution, and we can have risk monitoring. So first is that you keep monitoring the risk if it is occurring, then you have a system for mitigating the risk, and then you have a system for resolving. Once you have a risk, for example, a system has crashed down, then you have to develop a system so that the system can be brought back to a stable state. How the system can be brought back to a stable state. So basically these are the two steps which we undertake in case of risk management. So the last phase of the project planning will be project monitoring planning. So in this case we measure, that is, we decide how the measurement planning is to be done. So we measure the schedule, the size, the effort and the defects in the system, and then a decision is to be taken so that the project goals are met. So basically in this, the task of the project manager is to see that the system is working as per the schedule, it is making the best possible use of the resources which are there, and these are minimum defects in the system. So basically all aspects of the system are monitored, and then there are strategies which are used to control if the behavior of the system is sought to be deviating from the standard which has been set as per the requirement specification document. So this was all about project planning. We shall be continuing with a new topic in the next lecture. Till then, thank you.